screen sharing. Yeah. And this one. Okay, yeah. All right, here. Okay. And power adapter. All right. Today we start Module 3, SQL Basics. Yeah. So SQL, we will use two parts. The first part, basic SQL queries. Second part, complex SQL queries. Yeah. So before we do basic SQL queries, we want to understand SQL structure, some basic knowledge. Then we can start to do the queries. Yeah. So part A, understand SQL structure. 8.1. Yeah. First, basic concept, database schema. Yeah. First, let's look at the history of database schema a little bit. Yeah. So the meaning of database schema. Yeah. The current meaning, just a database definition. Yeah. People also call it schema. Yeah. The definition part. Yeah. All right. To clarify this, yeah, I talk about how to generate a database. Yeah. So remember, I give you a simple database script. The database script is used to generate a database. Okay? Yeah. So database script. Script in SQL. SQL commands. Yeah. Generate a database. A DB script contains two parts. The first part, definition part. Database definition. This part we call a schema. And the second part, the data part. Data part not included in the schema. So when we talk about schema, we do not include the data part, the business part. Yeah. But the history of this concept is not in this way. So here, let me briefly give you a history of this concept. Yeah. Yeah, specified during the database design. Yeah. So you need to write the definition, so that part, schema. Not expected to change frequently. I mentioned before, in the early design stage, we need to change quite a lot. Because at that time, we do not have a good idea on how to design a good database. So we need to experiment several ideas. At that time, we change our database structure frequently, but after several rounds of improvements, then it becomes more and more stable. So then we will not change much. Yeah. Although we need to, when necessary, we need to make an adjustment, especially when the business requirements change. You may need to change the database structure. Sometimes when you need to add new features, you may need to add new tables. Yeah. All right. Schema construct. Yeah. How to construct the elements, the pieces you use to define your database. Entity. Yeah. So what's the entity? Object, the business object you want to describe. That's the entity, business object. For example, student is an entity. Student is a business object. So we want to describe the information about a student. Yeah. Employee is an entity. Employee. Yeah. So the first name, last name, so all the basic informations we want to have for that employee, yeah, entity. So in a table, a row in a table, or a record, yeah, a record. But here, this table, later, I will explain. This table here, there are two types of table. The first type is the entity type. Here we are talking about this type. But there is a second type. Second type is not an entity type. Also important. Second type is the relationship type. Relationship type, yeah. Later I will explain the importance of this relationship type. Entity type, relationship type. These two types of objects. So typically we use to describe the business world, the whole business world. Yeah. All right. Represents a real world object, such as employee. Yeah. Yeah. But relationship, we do not call object. Yeah. Later you will see. Something. Think about a relationship between two employees, supervisor, employee, ordinary employee, supervisor, that kind of a relationship. Yeah. Yeah. Sometimes we need to represent relationship. You cannot use the object, the entity object to characterize. Yeah. So I will explain the difference later. Yeah. Attribute. Yeah. Because each entity, each object, you need to describe it through a set of attributes for this object, for this entity object. So a column in a table or a field. Each column, first name, last name, they are attributes. Age, birth date, yeah. So all those pieces of information. Yeah. So here, these three words people use frequently. One is attribute, another column, and a field. So these three words, they have the same meaning. Yeah. We are talking about the same thing. Yeah. Yeah. Different places, people use different names. Yeah. Yeah. All right. Represents some property of interest on an entity such as employee's name, attributes. Relation, then relation. So what's that relation? So relation, it's a formal name of a table. So when we use table, that's the name we use in the business world. So in the business world, we use table, okay, to talk to, in the basic terminology, but relation. So relation in our formal model. Formal model. So remember I mentioned that academic project. Researchers, they create this academic project, relational databases. In that academic project, we call table a relation. Okay? In the business world, most people do not call relation. Okay? Sometimes they may mention the relation, but usually people use table. All right. Table types. So now here I compare these two types I mentioned. Entity type, relationship type. Why it's important. First, entity type. That's the basic types. Basic object types in the business world. Entity type. Describe an object in the minute world. Minute world, that's the business world. So actually, part of the minute world, that's the part of the business world that your project is interested in. Because the whole business world, your project, you only provide services for one specific group of users. Only that part, the minute world, part of the business world. All right, describe an object. All right. But if you only describe objects, still not enough. Because sometimes you want to connect, you want to build certain relationships among those objects. So we need another type called relationship type. A relationship among two or more entities represents an association among the entities. Here, so let me explain the importance of these two types in the business world. So in the business world, we need to study. So we make abstraction of our business representation. So in the business, the representation, you represent typically using some abstract way. Here, I like to talk about, the graph theory. Graph theory. In computer algorithms, graph theory is a very important part of the computer algorithms. So what graph theory study? Abstraction from the business world. So a graph. So first, we need to define a graph. So what is a graph? A graph contains vertices and edges. That's simple. Only vertices and edges. Graph theory. Yeah. So graph theory, you can represent so many different things in the business world. For example, airline business. Airline people travel from cities to cities. Yeah. The cities, we use vertices to represent. Yeah. Each vertex represents one city. Yeah. Then, the flight between two cities, okay? Yeah. Two cities. Yeah. Yeah. That, so you draw a line between two cities, that's the edge. Or highway connect two cities, you can call it an edge. Yeah. So you can see, use these two basic concepts, vertices and edges, you can represent so many, the typical objects and their relationships in the world. Here you can see in our sequel, we also represent these two basic concepts. Okay, yeah. So object, so here, when talk about object, that's the same thing as a vertex in a graph theory. Okay? Yeah. Object, so you have many objects in your business. All right? Yeah. Then, among those objects, you may need to describe their relationships. Okay? Their relationships. Yeah. So many different. That corresponds to the edges. Edges. Okay. Edges, relationship. Right? Yeah. So here you can see, yeah. That's the simple abstractions. Yeah. Pretty general. Yeah. Simple, but you can cover the complicated situations in your business. Yeah. All right. Yeah. Here, relationship, we also use association or mapping. Mapping association, two objects. Yeah. So you want to make connection between these two objects. So mapping. Yeah. Remember last time I talked about M2M mapping, when I talk about Google search engines, keywords, URLs, right? Yeah. So if we use the examples we studied last time, keywords, they are objects, right? Keywords, one type of objects. URLs, websites, links, URLs, another objects. But if you only have those objects, not enough. You need to have relationship among them. Yeah. Yeah. Mapping keywords to URLs. And the URLs to keywords, that kind of mapping, relationships, also important. So in our SQL, we only need these two types of tables. Yeah. All right. Examples. Yeah. Yeah. Later, so for this class, we will use two tables. The first table, university. Second table, company. Yeah. I haven't posted the scripts. Yeah. So I will start posting these two database scripts soon. One we call the university. database. Yeah. So containing tables, entity tables like students, courses, yeah, sections, prerequisites, that, prerequisites, that's probably the relation type because you need to connect to the courses, prerequisites, courses, and grades, for example, the grades, we will see, And another database we call a company. Company database, that's our main database for this class. So all examples we use for our queries, we use this company database. And also in our homework, query questions, in our midterm, let me see. Midterm, I may like to give you some basic query questions. Midterm, and midterm about 1 month away from today, approximately about 1 month from today, before the spring break, or around, so or near, So I need to check with the syllabus, or that could be or after, but around spring break, All right, So. And the final also, we will use company database to write all our queries. All right, the script I post, so you install on your machine, so you can practice. So run the query commands and see the results. So fix the problems. All right. So in the company database, there is a special table called works on. Company, there is employee table, department table, project table, department location table, and a dependent table. All those tables from the names you can see, they are entity tables. Those 5 tables are entity tables. But the last one, number 6, works on. You can see works on employees, works on project. So basically, it's a relationship table between employee object and project. Works on project objects. Do the mapping. So then the mapping, so that's the only relationship table in the company database. All right. So a relationship between, so another example, a relationship between math problem and a category. So sometimes I also use this example. If we want to create a math question bank database, store all, large number of math questions, but we need to assign them, all those questions, to different categories: algebra, geometry, trigonometry, calculus, number theory, and so on. Okay? So then you need to do the mapping. Each question you need to map to different categories. Okay? It's possible you do M-to-M mapping. So M to M, one question is possible you map it to multiple categories. Yeah? Because one question you may use algebra knowledge, you may use, trigonometry knowledge, integral calculus knowledge, right? Yeah? So you may like to assign to several categories. Yeah. Each category, there are a large number of questions. Yeah. So it's an M-to-M relationship. Yeah. Relationship. Yeah. So the relationship type, there are these types. Okay. One-to-one relationship, that's one. Okay? Yeah. So one object can only be mapped to another object, one-to-one. Okay? Yeah. One-to-M. Yeah, people write this way, okay? So 1 to 1, 1 to M, M to 1, M to M, okay? Yeah. These 4 different types of relationships. Yeah. Yeah, because in database design, people need to draw diagrams, okay? So there are some graphic tools people can use to draw diagrams. Okay, yeah. So the relationships in this way. Yeah. All right. So allow M-to-M mapping here. Yeah. History of schema. Early versions of SQL did not include concept of a relational database schema. Yeah. So early version. Early version, when people create this relation model, it's very simple. It's a very simple model. Okay? Yeah? So, how simple it is. So the data is not well organized in this model. Yeah. So let's talk about SQL 1. Yeah, because SQL, there are several versions. SQL 1, SQL 2. So let's look at these 2 versions. Yeah, so here, yeah, all tables relations were considered part of the same schema. Yeah. So what's the schema at that time? Schema, everything stored in a DBMS. So people call it schema. Okay? Yeah, big umbrella, yeah, storing all tables. But those tables, when you work on the business projects, those tables are used for many business objects, not just one, so many. Okay? In other words, the tables used for multiple business applications, all the tables are together at the same place. They are not separated. Early version, tables for different business applications are stored in the same place without separation. Okay? Yeah. So it's very messy. Yeah? So you can see tables, table 1, 2, 3, 4, 5, a sequence of tables stored in this DBMS. But table 1, table 2, so those tables may work for different business applications, but they are stored under the same schema. That's the SQL 1 version. Definitely, it's not good, yeah? Because it's not convenient. You don't know which table belongs to which business application. Okay? Yeah. So from SQL 2 version, then tables for different business applications must be separated under their own database schemas. So this time the schema concept, really useful here. Yeah. If you only one schema, you cover all the tables, not useful. Okay? So now, one database can only have one schema. Different databases must have different schemas. Yeah. So that's the starting with SQL 2. Yeah. Then, no confusion. Yeah. Yeah. So that's our current case. Yeah. So, all right. Group together tables and other constructs that belong to the same database application under the same schema. Okay? Yeah. One-to-one correspondence. One database, one schema, one-to-one correspondence. Yeah. Yeah. So that's the current way we use. Yeah. All right. Yeah. So that's the history of the schema. Yeah. All right. 8.2, then database languages. Yeah. So in the relation model, so we look at the academic project, that situation. Yeah. All right. So when those researchers, they make that research project for SQL, of DBMS, SQL DBMS. Yeah. So they define this data definition language. So they say, so in order to define your databases, you need to use certain languages. You need to use a special type of language. Yeah. So those researchers call this language DDL. Data definition language. DDL. Right? How to describe the structure of your data. DDL. So that's one, type of languages. Yeah. Define schemas. Yeah. So when you write the table definition, you use DDL. Okay? All right. But that's not enough. When people do the queries, right? Yeah. So, view definition language. Yeah. View, you want to see, you want to view. Yeah. How to see the, different parts of the definition. Okay? So you want to view the constructs of the definitions. View definition language, VDL. So you need another special language to do that part. Okay? Yeah? All right. Specify user views. Yeah. How to, make specific views. Yeah. Define views. Yeah. All right. But another type, also important, data manipulation language. Queries. That's the data manipulation language. How to do queries. Okay? Yeah. DML. That one. DML. Okay? Yeah. So in the research project, so those researchers, they thought, you have to provide these three types of languages in this relation model. Okay? Yeah? All right. All right. Yeah, so this manipulation include retrieval, insertion, deletion, modification. Yeah. So that's our basic query operations. Yeah. All right. Yeah. 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 But now, although, you see three different languages, yeah, but all of them are included in the SQL. SQL contains all these things. Yeah. Yeah. So many times people do not try to separate, which part for DDL, VDL, DML. Yeah. People do not bother to separate these different parts of the language, yeah, in SQL. Yeah. Just treat the whole language, whole SQL language, so everything together. Yeah. Yeah. You don't need to separate them. Yeah. Yeah. So SQL is a comprehensive, integrated language containing all of them. Yeah. But sometimes when you see people discussion, in the technical articles, still you can see DDL. Yeah. You can see DDL a lot. Yeah. DML also a lot. Yeah. But VDL, not that often. Yeah. DDL definition, part, okay? Yeah, so that's the most. You see most. Yeah. So you only need to know what's that. Yeah. 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 All right. Just for your background. Yeah. All right. A combination, all these three languages. Yeah. But separation of them, yeah, not that important. Yeah. All right. Statements for constraint, specification, schema evolution is, yeah, I mean, yeah, right. SQL, so we know, we can do so many things, SQL. Yeah, question. Yeah.
For VDL, what do you mean by specifying view?
View, yeah.
Like the select statements and the view that we see if we do a query.
Right, yeah. So how do we present our data? Yeah, yes, yeah. Yeah, here, you're right. So the good question, yeah, because manipulation, we do the retrieval, right? Yeah, but the view part and the retrieval part looks overlap. Yes, yeah, good question, yeah. But, people, so here also, we can understand, the virtual table, the view, people define views, virtual table. Yeah. So that's because virtual table, people make views for some special presentation of the data, derive the data, but you need to present in that specific way. But here, how to separate retrieval and the views, we do not need to really separate. Yeah. All right. Yeah. So part 3, properties of SQL. Yeah. All right. Yeah. First, it's a standard language for commercial relational DBMS. Yeah. So here, I want to emphasize this standard, industry standard. So that means all DBMS vendors, if you want your product to be used in the business world, you have to adopt the standard, SQL standard, but for relational, okay? Yeah. For non-relational, then the standard different. Yeah. But for relational, that's the standard. So you have to adopt it. Yeah. All right. Yeah. It's a comprehensive database language. So it can do many things. Yeah. Containing programming. Yeah. Remember, when we define stored procedures, that's programming. Yeah. We can use SQL to do it. Programming language. We can treat it as a special programming language. Okay? But the programs we write, they can only run inside the DBMS. Yeah. DBMS. Yeah. That environment. Yeah. Both DDL, DML. Yeah. All right. It has facilities for defining views on the database, SQL, specifying security and authorization. grant permission. Yeah, different users, you can grant permission for different table, two different tables for different users. Yeah, you control that. Yeah. So very sophisticated. So you can see the SQL language, very sophisticated. Defining integrity constraints. Integrity. Yep. You know, the data, you know, foreign key, remember? Yeah, so last time we mentioned several integrity things. Yeah. Uniqueness, right? So those constraints. Yeah. Specifying transaction controls. Yeah. Transaction. Yeah. Last time when I explained advanced features, yeah. Transaction. So we did how to define a transaction. Yeah. Yeah. A block of queries as a unit. You cannot separate the queries inside that group. Yeah. All right. Rules for embedding SQL statements into a general purpose programming language. Yes, so this part. Yeah. For application programs, you need this part. Java, PHP, Python also. Yeah, Python can work with databases. Yeah. Yeah. So when those we call a general purpose programming language. Okay? Yeah. You know, even C++, yeah, general purpose programming language. Yeah. So if you need to access DBMS, you need a communication interface. Otherwise, you don't know how to communicate. Yeah. So the communication interface. Yeah. So, yeah, for different programming languages, it will be different. Yeah. So, I use Java and PHP to explain the difference. Yeah. Java interfaces, JDBC interfaces. PHP, we use functions. Yeah. For different DBMS, the functions, query, connection, the query functions we use different. Yeah. But Java, it's different. Java, all DBMS use the same set of programming interfaces. The program here, in Java, the situation is slightly different. So Java here, I talk about the Java technology, JDBC. That's Java database connectivity. Okay? Yeah. Java database connectivity. All right. Java tried to use a more efficient way to handle the database communication, DBMS communication. So what's that efficient way? It creates two sets of interfaces. Okay? One set for programmers. Programmers. Okay? Yeah. That programmers interfaces. So we used to write our, Java statements. But another set for database vendors. vendors to develop database drivers interface. Yeah. Another set of interface. Yeah. So the vendors use that interface to develop their drivers. Yeah. We do not know. Yeah. We as programmers, we do not need to know that interface. Okay. The drivers interface. Yeah. We only need to download the driver library files. Yeah. If we want to work with MySQL, we just download MySQL database driver library file. Okay, only one library file, yeah, included in our web project. If you want to connect to Oracle, you just download Oracle database driver, one JAR, Java archive library file, and include it in your library, in your web application library files. Then you use programmer's interface to write your code. Java, you use that way, special way. Yeah. So PHP, it's different. PHP, you do not need to download drivers. Okay? Yeah. So all the details are taken care of inside function definition. The PHP function call. MySQL something. Yeah. MySQL. Yeah. The function name, you can see MySQL there, right? So you can only use those functions for MySQL database. If you change to Oracle, you have to use Oracle something to do the query. But in Java, you don't have MySQL method name. No, never method name. Okay? It's a generic. In Java, you do database queries, all the classes, methods, there is no DBMS information contained. Yeah. Generic. Yeah. It's a generic. Generic means you can apply same functions, same methods on all different DBMS. Same set of classes, same set of methods. When you switch from MySQL to Oracle, you do not switch Java classes. You do not change Java methods. Yeah. But you change other things, okay? Other things, but not Java classes, not Java methods. Yeah. But you need to change several other things, okay? Java file you need to change, username, password, URL you need to change, query statements you may need to change. Query statements. Yeah. I mentioned before. Yeah. 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 Because although the standard language there, I remember I explained the extension part. Other than the standard SQL part, there is extension part. Extension part for different DBMS, it's different. So you may need to change your SQL step if you use any extension features. Yeah. All right. Structure of SQL. Core, yeah, here we talk about that. Core specification, that's the standard part because it's core, okay? So all DBMS should use this core part. Yeah. Supposed to be implemented by all relational RDBMS vendors. Yeah. Then specialized extensions. Then different vendors, they have their own specialized extensions. Yeah. So this part could be very complicated. Okay? So this part make your DBMS switch pretty hard. Yeah. The conversion, if involved extension part. Yeah. It's very common. Yeah. involved extension part, then you need to do a lot of work. Yeah. All right. Implemented as an optional module, yeah, but a lot of features. Yeah. So I can give you a few examples. Yeah. So let me finish this part, then I'll give you a few simple examples. Yeah. Consequence. Yeah. The consequence. In application programs, when you change the DBMs, you may need to change your SQL statements if involve extension part. Yeah. Yeah. Here, let me give you a few simple examples. Yeah. All right. Yeah. So in MySQL, there is a simple feature. There is a simple feature. Yeah. Yeah. So MySQL, SQL. Yeah. When we use the select statement, yeah, select. Yeah. Select statement, okay? Yeah. From a table. Table name. All right. Think about, sometimes your table could be very large. Yeah. For example, suppose we create a math question bank. Yeah. Think about, we create a table to store a large number of math questions. Yeah. I remember I did one. Okay. I did one. I made a math question bank myself. Okay, so I basically, part of the question I type into it. Part of the question I write program to pull, from different websites. Yeah. But eventually, when I count the number of questions, 33,000 questions. Very large number. Okay? All right. Then, when you do select, definitely most of the time you don't want to select the whole table, right? Yeah, ridiculous. Okay? So people use pagination. Page. Every time you only take one page. Okay? So here, we need a simple feature called a pagination. Every time you only select one page, you need to define page, all right? How large is your page? Where to start, okay? Yeah. So here, in MySQL, there is a keyword, pretty simple to use, okay? So that is, you use the keyword limit. Okay? Limit. You limit, okay? Only part of the table. Limit, you need to specify two parameters. The first parameter, start. It's an integer, comma. Okay? Yeah. Where to start? The first row. First row. Okay? Yeah. 0, you start from the row 1, because there is no row 0. Okay? Row 1, so row 2, and so on. Okay? Yeah. Then, page size. Okay? How many rows do you want to put in one page? Page size. Yeah. Question.
Does that happen in the app, or is that on the SQL side?
SQL? Yeah, SQL side. Yeah. Yeah. SQL side, but MySQL, extension part. Okay? Extension part. So here I want to explain extension. Okay? That means this limit keyword. Yeah. But if you move to Oracle, it's not available because it's inside MySQL extension. It does not belong to Oracle extension. Okay? Yeah. So when you move to Oracle, you need to search the Oracle document, how to do the same thing. Yeah. But much harder than this one. Yeah. There are two different products, right? Yeah. MySQL free, yeah, it's very powerful, but it's free. Okay? So many business small, mid-size, even large size. Okay, large size, as large as Facebook, Google, that giant. They also use part of it. Yeah, also use MySQL. Okay, yeah. But Oracle industry, banking industry especially, certain industry, so they need Oracle. Okay, they need advanced features from Oracle. Yeah, so very big business special, especially the banking, using Oracle. Yeah, yeah. So e-business use MySQL a lot. E-business, okay, but banking industry use Oracle a lot. Yeah, yeah. The reason is special features, many special features. Large number of special features. Yeah. When you compare the size, Oracle, you download several gigabytes, the whole DBMs. MySQL, several hundred megabytes. Why the size different? Pretty much 10-to-1 ratio, because extra business features.
Yeah, there are manufacturing companies use SMS.
Oh.
SQL Server Management Studio. I think that's Microsoft.
Yeah, yeah.
I think it's pretty similar to MySQL.
Right, right. Yeah, right. Yeah, many. Yeah. Because here, these two just, I use these two as examples to explain. Yeah. Many others, I'm not quite familiar. Yeah. All right, so here, this is example. Another example, also very convenient. Yeah. In MySQL, there is a simple feature. Okay, so when you create a table, many times you like to have a primary key. Later we will talk about it. Here I haven't explained the primary key, but you can see from the name, it's important to identify the rows. Yeah. Table, you have many rows. How to identify those rows? Okay, if you create primary, because primary key must be unique. Okay, to identify the rows. All right? But many tables, many business tables, they do not have primary keys. Okay? Do not have, so it's not very convenient to use. Okay? Because primary key, sometimes, if you look at the data, none of them is suitable for a primary key. Okay? None of them is suitable. Yeah? Because some product, something, it's hard to find, because if you use a student number is a good primary key. But first name is not good primary key, right? Last name, you combine first name and last name, still not good primary key. So sometimes for some products, it's not very convenient to choose a primary key. Yeah? Because none of them is good. Okay? In that situation, MySQL provide a special feature. It's internal primary key. It's called auto increment primary key. So just the 1, 2, 3 numbers generated automatically, but it used internally. Okay? Yeah. Not connect to the product directly. Yeah, but just the 1, 2, 3, 4. So it's called auto increment. Auto increment primary key. Okay? Yeah, very convenient. Yeah. So people use this a lot to identify the rows. Yeah. Otherwise, it's hard to identify. Okay? Yeah. But auto increment, this feature belongs to the extension part. Okay? So if you move to different DBMS, it's different. Yeah. It may not be available. Okay? So you need to find a different way. Yeah. So here you can see, when you do the conversion, you need to spend a lot of time on things like this. Yeah. Extension, the features in the extension part. Yeah. Yeah. All right. Yeah. So then, so this is my last slide of part A. Yeah. Yeah, SQL terms. Yeah. Here. Tuple, yeah, so you know the concept tuple because it comes from math. Math, so we use, A1, A2, like a vector, a sequence of numbers, in certain dimension. So we call it tuple. So then, in table, we use this concept. So each row, we treat it as a tuple, because each row will have column 1, column 2, column 3, and so on. Okay, column n. Tuple. All right. So then attribute column relation. So those just terminologies. But this tuple, so later we need to separate conceptually with another concept, similar concept we call a set. Set also another math concept. Tuple concept, math concept, these two concepts have different properties. Do not get confused. Do not get confused. Here I just say a few concepts. Because later we will talk about the difference many times. In set, we know how do we define a set? A group of elements, right? A group of elements form a set. But, so here, talk about set. A group of elements. But tuple also a group of elements, right? But they have different properties. In set, no order. No order. Order doesn't matter. Okay? So group of elements, you change the order, the same set. But here, order matters. You need to consider the order. Okay? If you change the order, you get a different tuple. Okay? The tuple is different. So that's one property, order. Another property, in a set, element, you cannot have duplicate element. Each element, it cannot be repeated. Okay? If it's repeated, it doesn't count. Remove it. That's in a set. But in a tuple, C1, C2, the same value, that's fine. It's okay. If they have the same value, you do not remove. Okay? They're allowed to have the same values for a tuple. Okay? And so they are the most important differences. These two. So sometimes in a table, sometimes we use set concept. Sometimes we use tuple concept. Okay? So you need to see the difference. All right, so let me stop right here. So we finished part A. So next time we will start part B. So a question?
No, I think you have one in the chat.
What?
For Zoom. Somebody had a question.
Someone asked question? Yeah, chat. Okay, let me take a look. Okay, question, last class mentioned, uploading. Right, yeah, I just want to talk about that. Yeah, good. Let me use this chance to say that, So, upload, weekend, right. So this weekend, because I made 2 assignments for 2 other classes, so I will make an assignment tonight, but because 2 different classes, when I'm making different days, so I said deadline also different days. Yeah, because I noticed one student took 2 of my classes. Yeah, so I want to make a deadline separate. So here I make this assignment today, then I set deadline to Friday, okay? But not this Friday, okay? So another week, then Friday. Yeah, because previous one, that one I make yesterday, I set on Wednesday. So 2 days separate, okay? Yeah, so one deadline Wednesday, another deadline Friday, okay? All right, so I will post, tonight, then you have at least 10 days to work. Yeah. Yeah, for students in 2 of my classes, so then you submit in 2 different days. Yeah. All right, yeah. Okay, yeah, yeah, sorry to get you confused. Yeah, yeah, so I haven't posted, yeah, so, all right, yeah. Thank you for reminding me, yeah.